Hi and welcome to DCO. My name is David Copete. If you're new here, what I do is I create parametric design scripts using Grasshopper. This is going to be a video where I'm sharing the entire process for creating the set of stairs from beginning to the end in detail. What we do is we start with creating the treads, then the stringer, and developing the railing and even a landing for the set of stairs. So if you're new, you'll be able to follow along. I'll also have the script available for free until the next video is posted. That way you can reference that in case you get lost somewhere. And that's one of the things that I do here is I provide you resources, tutorials, so you can learn how to use parametric tools for your own designs. So hopefully you're excited to see what this is all about, and let's get into the tutorial. All right, so to start the tutorial, the first thing we're going to need is to bring in a point. So we'll go here in Grasshopper. I have a brand new file. The units I'm using are going to be in inches. So what I'll do here is start with the point. I'll bring in a parametric point. Now we can always bring one within Rhino, but let's go here to construct, point. Then from here, we're going to create the initial circle of where the entire set of stairs is going to be. Now, you don't even need to use a spiral line segment for this. You can use any line segment to create the stairs that I'm going to show you. But here, since it's a set of spiral stairs, I'll go to a circle. We'll plug in the point into the plane input. I do like to route it through an empty point component. So this way we can change that location if we need to. Now let's pick a radius. So I'll go here to 48. And if you've seen the last tutorial, you'll see that some of the steps that I'm going over here, I've already gone through, but for creating a spiral pattern, which is a little bit different. Now we're going to move this point in either X, Y, or in any direction. But what I'll do here is I'll move it in the X direction. So you'll see here, we'll bring in the move component, move the point in the X direction using the same input as the circle. Now we're going to be creating the circle array. We can do that using polar array, but I like to use the series component. This way we have a little bit of control and we can learn how to use this for other designs. Now, what we need to do is create a step, and the step for a circle is going to be based off of 360. So I'll go here to 360 divided by how many points I want. So this is going to give me the step angle. Now let's keep it here at 10. So it'll be 36 degrees that it'll step by, and the count is going to be 10. Now we're going to take the series component, which are all of these angle rotations, and then rotate the point, which is the one that we moved over to the side. So we'll bring in the point into the geometry input. The angle will change it to degrees, and then use this as the input. So now we can change how many points we have, and that'll give us a higher number of detail. Then what we need to do now is create the vector in which we're going to move out all of these points. So I'll create a line segment between the start point and the end point. And now with these vectors, since they're tied to each point, we're going to move these points. And a line segment is a vector, so we can use amplitude to give this a value of how much we're going to move these out by. Since we only have one number here, so let's say 15.5, we're moving all of them at the same time, and we want to move them progressively out to create the spiral. So what we need to do is, once again, bring in the series component. We can copy the count, but we're going to change the step. Now we can plug in the series into the amplitude here. And notice that now we're creating the spiral pattern that is stepping out by 23 at every point. So let's decrease that to something like 10. And now with this, we can hide most of the inputs here. We want to keep the circle because that's going to be where it starts from. And now we can plug in all of those points into an interpolated curve or a NURBS curve. What interpolated curve does is it goes through every point, creating the outline of what the points create here. Now let's hide all of the points. And one of the things you may think is, why don't we use the points since they are equally spaced as the treads? Well, because we actually need to control the length of them. So now in a bit, I'm going to show you also how we can take this number here of 360, and we can also multiply this number by a lower number and a higher number to be able to create a spiral that wraps around itself. All right, so let's create the base offset for this to show you where the stairs are going to go. So let's offset this curve. And if we go to top view, we can see where it's offsetting. So it's offsetting to the outside here, which is what we want. And this is going to give us the width for the stairs. Now this is just the outline, because what we're going to do is actually move some points over to that location. But this will give you a rough outline of how big the set of stairs are going to be, and if we need to even decrease the step. So we'll step the amplitude for the spiral out by 2.5. And we do need to keep these two consistent, because depending on how many points we have, that's going to determine how many times we move out the pattern. All right, so here, let's now take the next step, which is creating the treads. So for the treads, what we need to do is divide this using horizontal frames. So I'll bring in the next component. And now it's going to ask us for a count. So let's say we had 20. Here's the thing. If we want to be able to control the minimum length of the tread, obviously it's going to get a little bit bigger as it goes out this side. But what we need to do is now take the step of knowing how we can control that. So we'll bring in the length component. We'll plug in the curve into the length component. So we have 685. And we're going to divide that by the minimum size of the tread. So for me, we'll make it a 12. And if we take that length divided by 12, it'll give us a number. So it'll be 57. And so now you know that between here and here, you have a minimum of 12. And for that, you have to have 57 horizontal frames. Next, we need to look at the horizontal frames and understand that every single one of these is going to be its own reference. So now we need to take this point and move it relative to this. Now, if you look at this, this is the red X direction. This is the Y direction, and up is going to be Z. And we know that because when you look at the origin XY coordinate system, we know that X is the red one, Y is the green one. And so now we're going to move all of these points here using amplitude. But since we only have these as frames, we need to deconstruct each plane into the X, Y, and Z vector. Now we know we want the Y vector. We know we want the amplitude to be 48, or whatever number this is. We'll just make it 48. And we'll use that same slider that we used as a reference line. Now that we have the vector, then we can move each point. So this is going to, when you plug in the deconstruct plane into the frames, it'll give you the origin point. So let's bring that into a point component. And now we can use this as the points we want to move. And here's the vector. Now notice that the vector, the positive vector, is going to be in the wrong direction. So what we need to do is bring in the negative component. So we know that it's moving it to the other side. So now we can hide all of the reference frames. And notice that now we can increase the tread size, and it's going to give us the minimum, and it's going to get larger as it comes out here, which means that this could even get smaller, right? Because where it's actually critical for you to have a large number is in the middle. So let's keep it at 12 here. Now, what we'll do here is to keep things organized and to know what we're doing here. I'm going to take these points and put them into another component. That way we have them next to each other. So this is going to be the original points that we subdivided. And these are going to be the ones that we moved out. Now we can disable the preview on the previous portion of this and connect the start to the end point. Now, if you're getting lost or you don't know what I'm doing here, and also if you're seeing things a little bit different, make sure that you have display, draw icons, draw fancy wires, and draw full names. That is how I'm displaying my information here. But also you can always download this and see how it's plugged in if you get stuck somewhere. So now that we have this, we're going to turn it into a surface. So we'll go to Loft. Now the options here, we're going to go to Loft Options, right click, and change it from normal to straight. And then go to Commit Changes. When you do this, it'll turn all of those into their own individual surface. And so we can now hide those line segments if we need to. And we're going to take this and move them up, stepping by the tread height. So in the same way that we stepped up the points and stepped them out little by little to create the spiral, well, we're also going to take these and explode them or deconstruct it. And now all of these spaces, which we have 57, That's another thing that we can have as something that we can look at. So we'll bring in a panel. We'll bring in a list length. And when we flatten, or when you have it just as one list, it'll tell you how many we have. So we have 57 treads. And so with this panel and list length, we can keep an eye out to know how many treads we're creating. So next, we need to take those faces and move them up. So we'll go to a move component. We're going to move it up in the Z direction. And we have 57 of these, but we need to step this one up by 6, this one up by 6, but progressively up. So what we need to do, so this one by 6, this one by 12, this one by 12 plus 6. So what we'll do here is create a series component. And since we know how many treads we need, we can use, I'll actually bring this down here. We'll use the count of 57, stepping by 6, and starting at 0. So now we have the spiral created, but we can change the height of each tread. Now typically, the treads in inches are going to be 6-inch maximum. So you can always bring in a component or a slider that has more decimal points. This way you can make it a little bit smaller, but unless you're doing residential, which is 7 3/4 height, you can keep it here at 6. Now it also depends on your units, but I'm just showing you all the steps here. Now here's the thing. So now we've got the surfaces moved up progressively by 6 inches. So what we need to do now is extrude it by the same amount. So extrude, direction, in the Z direction. But this time we only need to extrude them all by 6, because since they've already been moved up, we can plug in the 6 into the Z vector and then extrude those. So if you've seen the last video, you saw that what I did to create the structure for this is create the stringers to be on the outside. And then that is what covers what the steps look like. Now at this point, we can go back to the top view. We can see that this is all the way out here. So we can even decrease the step number. And we can increase the minimum size for each tread. The process that I'll be taking for today's video is going to be a little bit different, but if you want to see the one where I created the side rails with glass and a handrail, you can see the other video. In this one, I'm going to be taking a bit of a different approach. Here at the beginning though, you'll see that if we want to change the spiral set, let's say we don't want it to go all the way around. Here's where we need to go back to our number of 360. Do a multiplication. We'll go between 0 less than 1.00 less than 5. So it creates the slider between 0 and 5, and it sets it at 1. So now we have 360 multiplied by 360, which keeps it the same. But now we have control in terms of if we don't want the spiral to go all the way around, or if we want it to wrap out further. Now this causes some issues. Let's say when you wrap it around too much, some of these get too close to the start. But this now gives us a little bit more control, and we can see it easier once we've stepped it up. If we would have done this before we stepped it up, it's a little bit difficult to see how that works. And it's also good to have the base curve here because we can see just by moving the sliders around how much and how close we're getting to one side. Now here, the issue is that when we have too many treads, so here we have 33 treads, if we have too many, then if we have more than 20, we're going to need a landing at some point. And so that's going to be the next part I'm going to show you, is how to take all of these steps, because they step by 6, how to introduce at the 20th tread a landing. But first we need to look at all of the data that's coming into the Z vector. So let's go here to a panel. We could do quotation marks. That'll bring in a panel. And if we look at this, we'll see that at 20, we have 120. So we need to know the height that this is at. So to pick one of those items, we'll go to list item. We'll plug in all of those points or all of these numbers into the list. And we'll need to pick the 20th one because that's the 20th tread and the location of where we want to introduce the landing. The next component is going to be insert items. And with this one, there's a few things we need to plug in. First, the list, which is going to be the same one as this list. So I'll double click on the wire to create that relay and use that output from the relay and plug it into the list. Now here, we'll see that the output, we still don't have anything working. That's because there are a few things we need to do is, first, what item we want to introduce, which is the item here. And that's going to be 120, which is the height that we want at the 20th tread. So we have this one into the item. And indices, or which one we want to introduce it into, is going to be 20. Let's organize this here so you can see how things plug in. So now let's look at the data. So we'll bring in a panel again. And this part's a little bit more advanced because we're dealing with the information and how it's arranged within the items. So we'll plug this one into the input, slide this down to 20. And you'll see 114, then 120, then 126. And then I'll copy the panel over, bring this one in. And now it's 20 is 120, 21 is 120. So now we have two that are at the same height, But what happens is that introduces an extra item. So now that we introduced one, now we have to remove one of these. So looking at this list, now we need to do a call index and remove the last one. So we'll plug in the list into the input. And the last one is -1. So if we bring in a panel and we do -1, now you'll see, so I'm taking it slow here so you can see it. Now you can see that we have at the 20th and 21st, we have 120. But down here, we still have 32 items total, which is 32 items total, which is what we need because we're going to be moving this. Even though it says 32, we have 33 because we start at 0. So now I'll move this over, and then we'll be using this as the input for that. And now we have control here as to where we want that landing to be. Now here's the thing that's a little bit different is that we've only done this to only 2 treads, which if this is 12 inches and this is 12, that would be 24, which is not enough for a true landing. So you can add more items, but this is the way to do it. We have the index here of 20. Now we need to do that again and plug in this item into this item. So we're doing this twice, but that means that we need to do -1 and then -2. Actually, no, it's going to be -1. And once we have that done here, then we need to take that list again and subtract it by 1 more. So this is part of what happens here is it's not necessarily scalable, but once you have one landing, then with just this one, you can control where that sits. And since you have 3, well, that's enough for it to be a landing here. So we'll keep it here at 20. And also this, if you have 33 treads and you want the landing to be exactly in the middle, then we can do 33 divided by 2, 16.5, and it will place it at 16.5 here. So like I mentioned a little bit earlier, if this is a little bit confusing or you don't really get it, this is something that takes a little bit to practice. And I would recommend downloading this for free as it's available when I post it. So you can see how things plug in and you can practice a little bit. I also went over all the steps here, so you should be able to do exactly what I did here. Especially because I have everything displayed in the way that, honestly, the way that I'd like to see it displayed. A lot of times I look at tutorials and they have it displayed in a different way where you can't really see the icon. You don't really know what the inputs are. And that makes it a little bit more difficult, especially for someone that is a very visual learner. So now with this, now we can move on to creating the rest of the script. So now to create the stringer, we already have most of the information set up. We've got the array going up. Now what we need to do is go back to where the points are. And we need to use this exact same component to move them up progressively. So we'll start with the inside points. So we copied the same one as the one for the treads. Why? Because now we have these set of points that are moved up. And we're going to do that both to this one, and I'm copying it, and then to these points. Now for this one, I want to use a NURBS curve. Now what I'll do is I'll develop one of them and show you how we're going to do the exact same thing to the other one. So we can save a little bit of effort here by doing it to one and then copying the steps for the other one. So let's hide the points. We'll take this interpolated curve. We're going to, or this NURBS curve, and we're going to offset this curve. But what's important here is that we bring in a plane in which it's going to offset. So we'll go here to XY plane, which means it's going to offset using the ground plane, I guess, if you think about it. So now we'll take this, offset it. We're going to offset it both to the inside and to the outside, which means that since we're using this as the center line, let's go here to 12. Since we're doing this to the center line, from the center line, then 12, we actually need to divide by 2 so that we do 6 to one side, 6 to the other side. So this will be negative. And for the stringer start and end, we need to extend it. So I'll double click into the output for this curve. And here we're going to create a modification of an extension using extend curve. And we'll extend the start and end point by using a slider here. So notice now that this goes past the end and start. And that's good because that's what's going to help us create the stringer and also create a bit of an offset here. So now that we've done that, we're going to use that as the input. And notice that we've done that here in 3D. So now we'll take these two offsets. We'll hide the one in the middle. Now we have this, that's going to be the extension. Now we have this one as the true dimension of how much that offsets. So now we'll take these, move them up. So we'll do it just to one first, this one, in the Z direction. And do the same thing to the other one. Now we also need to do that to the middle one because that's going to serve as the location of where the railing is going to go. Now it's not as critical as these two because those are actually where we're going to loft them together. and extrude it down to create the stringer. So let's go here to extrude, C, in the Z direction. We'll use the negative component. And we'll use a slider. Now you're probably seeing that I'm copying a lot of sliders and components. That's just to save a little bit of time. And we'll use this as the extrusion. Oh, that wasn't plugged in. No wonder. Okay, so now that that's plugged in, you'll see that this becomes a stringer, and you can make it as to go as far as it covers the treads here. That's also determined by how far up we move this. So that's the width of it. And then how far up we move this. So if this doesn't go that far up, then the bottom one doesn't need to be extruded as much. Now here's the thing. This goes all the way out to the end here, and I don't want it to do that. So we need to bring in an extend, but extend is going to be in the negative direction. So we'll extend these curves in the opposite direction. And this will help so that the railing sits right on the stringer here. Rather than it sitting right at the edge, that's sometimes creates a conflict. And it also gives us a little bit more control here. Now we're going to take this and extrude it up. So I'm copying that extrude and overwriting the input. Now with this surface, you can probably see that there are a lot of different ways that we can develop this, right? So what we'll do now is create the handrail and then figure out, well, no, let's first develop this. So we'll take the extrusion, we'll divide it using isotrim. And when we use isotrim, we also bring in divide domain squared. So as you can see here, we can already take this and create a set of railings with this. So maybe that's one of the options that we can do is taking this. They are individual 100 of them. You can change the inputs using a different U and a different beat. Now what happens is, since they are individual surfaces, we now need to join them using brep join. And even though we've joined them, they still have the creases, which means that if we use a deconstruct or a brep edges, we can select just the outside ones as compared to the inside ones, and this gives us a little bit more control. So the naked ones will be on the outside, the interior ones will be the ones here on the inside. So by using a pipe component, we'll use a radius of, let's say, 1.5. Caps, we do want them to be round. And so we'll bring in the naked curves into the input. Now here's the thing. Notice that they are individual separate ones, so we can actually join those together. And now we're going to do the same thing, but to the interior ones, and just keep them a little bit smaller. Now, obviously, this is just one direction of developing this, but we have control in terms of being able to increase how many subdivisions we have here. Same in the vertical direction. So like we can change that. And we also still have this to be able to cover it or to create a pattern that goes through it. So we've done all of this to just one side of this curve. Now we're going to do all of these same steps, but to this one, to the other side. So what we need to do is copy the steps, but we won't copy the sliders. So we'll select everything, holding down Control, or if you have a Mac, it might be Command, to deselect the sliders because those are going to be shared. And if we don't copy those, then it'll copy the components and not the sliders, which makes it a lot easier for us to change the design, not just have one side change as different than the other. So I'm sliding it down, tapping Alt to create a quick copy. You can always do Control C, Control V. And we'll plug this one into the curve. Now what it does though, when you copy it like that, it does create a little bit of a mess here. And the reason why is because since the sliders get copied down here, well, I do end up hiding the wire display input for all of those sliders. You can always leave them if you want to, but what I like to do is you can always, when you see this symbol, you can always select this and know where it came from. All right. So here we have the final look for this, and all of the inputs we can still change. We can even add another set of landings if we need to, but this is going to show you a few things. So here to conclude, let me go over some of the things we did today. We started by creating the spiral. Then we subdivided it using horizontal frames and moved them relative to those frames. Created a loft to create the treads. Deconstructed those into their own individual ones, which we know we have 33 different treads. Then move those up using a series component by moving them up by 6, which is the height of the treads. Then after doing that, you saw that we had too many treads, so we need to introduce a landing. And for that, we added 2 different heights that were the same for the 20th, or half of 33 here. We can also pick a specific number. So if we wanted it to be at the 20th tread rather than halfway, we can change that here. And with this, then that was plugged into the array. Now we can also choose not to do that. We can also choose not to create a landing. So here, maybe this is something that I can do, which is create a relay, create a number. So this is, I'll hide the input here, or the wire, and call this no landing. So here I'm still using this part of explaining it, and then this one with landing. So this one with landing, this one without. Then creating the same array that we use for the treads to create these NURBS curves, which were used to create the stringers. Now the stringers are going to be what the treads sit on. And from there, using the middle of that, we created the railing on each side. What we did first, though, was create it on one side, then copied the entire portion of the script down here without the sliders. So that way we can control, let's say, the extension of how far each ledger or stringer goes here. Now this is going a little bit far in. All right. So hopefully you learned a few more tricks. This one was a little bit more advanced, but I feel like a lot of the steps here are pretty practical that can be used in other designs. So thank you very much for being here. Download the script if you got lost somewhere, or if you have any questions, or if you even just want to add it to your library. And I hope to see you in the next video.